All right, folks, it's Bass Action back in action here. In this video, we're going to look at some graphs with x as a function of y. Traditionally, when we are looking at our graphs, we're looking at graphs with y as a function of x. So when we look at them graphically, we're looking for them to pass a vertical line test. Most of these, A, B, and C, are not going to pass that test because these are graphs with x as a function of y. Now, there are a wide variety of ways that we can do these. I'm going to show you the one that I think is going to be the easiest for you because it connects with how we've looked at functions and equations up until now. Also, when you do these types of problems in your calculus class, they're going to generally look about this level of difficult in terms of transformations. You won't have that wide variety of transformations that we've been dealing with in most of our other functions so far. So what we're going to do on these, again, there are other ways to do this. I'm just going to show you the one that I think is going to be the easiest, quickest transition for you, is when we look at these, we're going to get rid of this f of y. Remember, this would normally say f of x for us. We're now going to replace f of y with just an x. So we would, in the past, we would have changed that to the y, but now it's going to be an x. Now, if we rewrite this equation, we just solve it for y, so it looks like something we're used to doing. We can take our square root of each side, and then this equation turns into y equals plus or minus the square root of x. Well, this is now an equation that we absolutely know how to do. It's just two equations put together. It's y equals the square root of x and y equals the negative square root of x. So all we need to do is graph each of these separately. Really, we're going to graph one and then reflect it. So remember, if we were just graphing y equals square root of x, we would have a point at 0, 0, we would have a point at 1, 1, we would have a point at 4, 2, and we would have a point at 9, 3. Of course, for this one, this is just the reflection over the x-axis of the previous one, so we just reflect all those points across, and we instantly have this nice left-right, what is called a left-right parabola. So that's going to be our easiest way to do that type of problem. We can apply that same idea if we come down here. Now we have a vertical transformation of this, or what would look like a vertical transformation, I should say, but it looks a little strange because our x's and y's aren't in the same places. So if we want to really understand how this transformation is going to work, what we're going to do is, again, we're going to get rid of that g of y, replace it with an x. Now let's start solving this for y. Well, that means that we're going to subtract that 3. Again, we'll take our square root of each side. So y is going to equal plus or minus the square root of x minus 3. So now what looked like that vertical transformation earlier, we can see in terms of our actual graph is actually a horizontal transformation. So having our variables rearranged here can be a little confusing. So we can do a couple things here. We can take this equation, think back to what we did here. Now that we know that this is just a horizontal transformation of that, and we could just slide that over, or we could take this equation and separate it like we did a moment ago, and we could write the two separately, and then graph this one and graph the reflection. I think that just shifting this one is going to be our easiest. So I'm going to go ahead and do that. We'll just move everything over 3 units. Again, hopefully I'm counting these right. This time I'm going to end up going off the grid. So I'm just going to stick with those. Not my best looking parabola, but it'll work. Now, if you're catching on to this pattern, then you're going to recognize that this looks like a horizontal transformation, but it's actually going to end up being our vertical transformation. So let's go ahead and solve this one. Replace that with our x. Now we're going to take our square root first. Let's put our plus or minus in there. We don't ever want to lose that. So that's going to get us y equals 3 plus or minus the square root of x. And now we can see that vertical transformation. So looked like a horizontal because it's that adding and subtracting inside the function. But because the variables are rearranged, we have to kind of pause and think about that a little bit. So I would really suggest when you encounter these in your calculus days that you do that. Just do this quick little rewrite so it looks like something you're familiar with. You're going to be a lot less likely to make a mistake. So now again, we could separate this like we did here and like we did here, or we can recognize we know how to work with this transformation, this vertical shift. So we can take our first graph and just shift everything up 3, 2, 3. Sorry, right there. And now I'm just taking each of those points and I'm moving them out. And then we're effectively reflecting them down. Sometimes students even like to draw in that what would have been the axis of symmetry. That's sometimes helpful. Oop, I put that one in the wrong spot. Didn't count that one very well. Ooh, I'm not winning any points on my graph here, but you got the points. Same thing over here. Sometimes seeing the equations in terms of y can look a little bit weird. This one's going to be a lot easier for us, though. This is going to give us an x plus 4 equals y, and sometimes that's just a little bit easier to see it in that notation. So we've got our y-intercept of 4 and our slope of 1, and now we can easily graph in those lines. So just a little quick little tip there, and rewriting those in terms of a y equals will make that process a lot easier for you.